in the last class, we discussed about the Thevenin theorem, and I discussed one or two problems based on the Thevenin theorem. Today, I will try to cover the maximum difficulty level related to the Thevenin theorem. If anyone has any doubt related to any point, just raise your hand. I will clarify your doubts. This is right. So here, I will start the today's discussion with this problem, which is the problem number 3. Now, what is the statement? In this case, the statement is calculate current in 8 ohm resistance for the network shown below using Thevenin theorem. In this case, we want to calculate current in the 8 ohm resistance using the Thevenin theorem. Now, I will apply the steps. Just we discussed in the last lecture, we have the 4 steps for solving the problems based on the Thevenin theorem. What is the step number 1? Remove the load resistance and redraw the same circuit. I will apply the steps and we will try to find out its calculation or its solution. Now, to begin with, I will start this discussion. Here, to begin with, in this case, I will start the discussion. Now, what is the first point? Removing the load resistance and redrawing the same circuit. I will start, we will remove the load resistance and we will redraw the same circuit. I will write the same. Redrawing the same circuit. Is it right? Yeah. Now here I will redraw the same circuit here. How will be the circuit? It will be something like this. There is the resistance, there is the battery, then it is something like this. And we are removing the load resistance. This is right. Here is the terminal A, this is B. I will give some terminals. It is A and this is B. This is 4 ohm resistance. It is 3 volt. This is minus, this is plus. Here it is 3 ohm resistance. This is 6 ohm. This is 5 volt. This battery is 25 volt. And this is the 2 ohm resistance. These are the terminals A and B. So here our aim is to calculation of the potential at this point, which is nothing but the VTH. Is it right? That is the calculation of the VTH. But for the calculation of VTH, voltage between these terminals, what we have to do? Look at carefully. If we are traveling from the B towards A, this potential plus this potential will be the VTH. For that purpose, we have to calculate current in the 4 ohm resistance. But in this case, we have the 2 loops. This is loop 1, this is loop 2. Is it right? Means first we have to use the mesh analysis and we have to calculate current in this branch. Is it right? Otherwise, you can use any method. Just our aim is the calculation of current in this branch. You can use the superposition theorem, you can use the mesh analysis, nodal analysis. If we are using the mesh analysis, this is loop 1, this is loop 2. Apply the KVL to the first loop, apply the KVL to the second loop, find out its equations. Or we can use a direct inspection method. This is loop 1, this is loop 2, prepare its matrix and find out the value of the current in this branch. Or we can use the nodal analysis. If we are using the nodal analysis, this will be the node 1, this will be the ground node. Because this is not a node. Okay? A branch open. This branch is open. That's why I will assume while calculating the current in this branch, I will assume this branch, this part of the circuit is not available. This part of the circuit is not available. In that case, this will be the one node. This is one branch, second branch, and this complete is the third branch. And calculate current in this particular branch. You can use any method, believe me. Is it right? This is loop 1, loop 2. We can use KVL to both loops and we can find out the current in this branch. Or we can use the direct inspection method. We can calculate current in this branch, or we can use the nodal analysis method. Here, the simple trick will be the direct inspection method. Is it right? But I will use the nodal analysis because I want to make you comfortable with all the methods. Is it right? That's why I will assume this is as one node, its potential is a VA. This is one branch and its current is I1 maybe. This is the second branch, its current may be the I2, and this is the third branch, its current is I3. You can use any method, but here I'm using the nodal analysis method, and this will be the ground node. You can use any method that I'm repeating again and again. Is it right? Our aim is the calculation of current in this branch. If we are using the nodal analysis method, here I will write applying KCL at node A. If we are applying the KCL or Kirchhoff's current law at the node A, apply the KCL and prepare its equation. How is the equation? If we are applying the KCL here, this is incoming, this is outgoing, and this is outgoing. This equation will be I1 is equal to I2 plus I3 is the equation. This is right. Find out the I1 first. We will try to find out the I1. How is the I1? Now look at this I1. Here potential is 0, negative to positive plus 25, 0 plus 25 is nothing but 25 minus this potential which is VA divided by resistance of this complete branch which is the 2, which is equal to I2. I2 is the current in this vertical branch. How is this value? VA minus 0 or VA, we are traveling in this direction, positive to negative, that is minus 5. This VA minus 5 divided by, this is, I will use capital, VA minus 5, this is VA minus 5 divided by resistance of this branch which is the 6. Is it right? Plus. Current in this branch, potential at this point is the VA, then negative to positive plus 3, VA plus 3 divided by resistance of this branch because here potential is 0. This VA plus 30 minus 0 divided by resistance of this complete branch which is 4 plus 3, 7. Is it right? It is something like this. Now I will simplify this equation and then we are in a position to find out its current and then we are able to find out its potential which is VTH. If I am simplifying this equation, it will be 25 divided by 2 minus it is VA divided by 2 which is equal to, it is VA divided by 6 minus it is 5 or 6 plus it is VA divided by 7. Is it right? Then plus 3 divided by 7. Just I have separated the terms from this equation. यहाँ से मैंने just term को separate किया. That's it. Nothing else. If we are shifting this VA to the next side and if we are taking the VA as a common, then it is 1 by 2 plus it is 1 by 6 plus it is 1 by 7, which is equal to the constant. Here, this constant I am shifting on this side means already the constant on the left hand side is 25 divided by 2 plus it will be 5 by 6 minus it is 3 by 7. Simplify the equation on the left hand side and right hand side and find out the value of this bracket. How much is this bracket, which is equal to how much is the constant. This potential is a VA, and from this equation we are in a position to find out its potential, that is a VA. I'm expecting the answers from your side. First, find out the value of this bracket. Yes. Anyone? Yes, Avinash.
Sir, VA 0.80.
How much?
0.80.
0.80. 0.80 VA. 0.80 into VA, which is equal to, how much is this value? Anyone? Rishikesh, Sujit screen minimize, Ruchira, Saurabh. Yes.
12.90.
12.904. 90. Yes, I will unmute to someone again. Saurabh.
0.80 VA cut to 12.91.
91. 12.91. Just I will check with another someone. Rishikesh.
12.
How much? Yes. Akash.
Sir, 12.90.
90. Okay, fine. Then how much is the VA? This VA is equal to 12.90 or 12.90 divided by this 0.80, which is equal to how much is the value of VA? Yes, anyone? Unmute yourself. Avinash, Saurabh, anyone? Yes.
16.12.
16.12. This is 16.12 volt is the value of the potential VA. If we know the VA, then we can find out its value of the current in this branch. How much is the current in this branch? I3. We are interested in the calculation of I3 only. What is the equation for I3? VA plus 3 divided by 7. This is VA plus 3 divided by 7, which is equal to 16.12 plus 3 divided by 7. How much is the value of I3? Yes. Yes, anyone? Unmute yourself.
2.73.
73.
2.73 amperes. Yeah. 2.73 amperes. Is it right? Now, if we know the I3, then find out the value of the VTH, Thevenin's equivalent voltage, which is modulus value. We are traveling from the B towards A. If we are traveling from the point B towards A for the calculation of this potential, then how much is the potential? Now look at carefully. We are traveling from the B towards A, means we are traveling in the upward direction. We are traveling in the positive to negative, which is minus. How much is the potential? 3. How much is this potential? Now look at how is the direction of the current? Downward. This will be the plus and this is minus. Is it right? If we are traveling in upward direction for this branch, negative to positive, which is a plus. Resistance is a 4 and its current is I3, which is 2.73. Simplify this value and find out its value of the VTH, that is Thevenin's equivalent voltage. Yes, anyone? Tell me the answers. Do it fast.
11.92.
11.92 volt is the value of the VTH. Is it right? If we know the value of VTH, anyone? I will take that from someone. Correct a value?
Sir, 7.92.
7.9.
Yes.
This is not 11.92.
Yes, sir.
7.92 volt. Is it right? This is 7.92 volt. If we know the value of the VTH, the next is the calculation of RTH. That is the next same thing. For the calculation of RTH, load resistance is removed. And all sources are replaced by respective internal resistances. Is it right? How will be the figure for the calculation of RTH? Now look at it. If this load resistance is removed, this source will be replaced, this source will be replaced, and this source will be replaced by its internal resistance. This figure will be something like this. Is it right? And this will be the terminal A and B. It is A, this is B. It is 4 ohm. This value will be 3 ohm. It will be 6 ohm, and this will be the 2 ohm. Use the series and parallel combinations and try to find out its value of the potential. Now here in this case, if I am trying to find out its value, How will be the case? That I will show here. This is right, in continuation with this. These two resistances are in parallel combinations. This I will find out its parallel combination. I will name that value. And this will be the next figure. You're getting me? Here is the point A. This is point B. It is 4 ohm. This is 3 ohm. And how much is the parallel combination? Yes, anyone?
1.5.
It is 1.5 ohm is the parallel combination. Is it right? If we are simplifying this figure further, these two resistances are in series. This is next figure will be something like this. Here is the A point, this is B point. It is 4 ohm. And its series combination will be 4.5. This is 4.5 ohm. Is right. And finally, we are interested in the calculation of RTH, which is parallel combination of these two. This 4 into 4.5 divided by this 4 plus 4.5. Find out this parallel combination and which will be the RTH. Yes.
$2.11.
It is 2.11 ohm is the value of the RTH. Is it right? If we know the RTH, finally, I will come to this point. If we know the value of the RTH, then finally we can find out its current. If we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. This is right. How is the Thevenin's equivalent network? It is something like this. And reconnect the load resistance which is removed in the step number 1. This is A and this is B. RTH, we have calculated this value. It is 2.11 ohm. VTH, we have calculated its value. How much is the VTH? It is 7.92. This value is the 7.92. This is 7.92 volt. This is 7. And how much is the load resistance? It is 8 ohm. This is 8 ohm. This I will reconnect the load resistance which is 8 ohm. Here it is the load resistance. This is 8 ohm. And now calculate current in the respective branch which is IL. Now here IL is equal to, how is the formula? Total voltage which is 7.92. This is 7.92 divided by the total resistance which is 2.11 plus 8 is its value. Find out its load current first.
0.78 volt ampere.
0.78 amperes. Now what value we are interested in the calculation? Calculate the current in 8 ohm resistance. And this is the answer. We are interested in the calculation of the current in this 8 ohm resistance which is 0.78 amperes.